The amount of water required for a typical domestic house. So in the UK, the average is about 150 litres of water per person per day. So that gives you an indication of how much water you're going to need. So basically, you'll use 80 litres every time you run a bath, 45 litres for a 5-minute shower, 50 to 100 for a washing machine, and 12 to 20 litres to run a dishwasher. So what we have here is a little link to a website that allows you to calculate how much water you think you will use in a year. So what you want to do is calculate how much water you would use in your own house. So go to this website here, cambridgewater.co.uk, click on that link and just work through it and do a little calculation to see how much water that you think that your own personal use and your own family would use in the course of a year. So it's quite surprising the amount of fresh water that you'll use in your house in a year. But how much water you used, the calculation done there is an average. It's based on a number of behavioural assumptions, and it's not possible to ask an end user for every detail about the water use of appliance, exactly how they're used, how often they're used, unless you're going to meter someone's water use. And in areas where there's no water metering, it's very difficult to get out an exact figure on the annual amount of water use. So you have to make quite a few assumptions. But in most instances, what you're doing is making an assumption about the general household water use. And some of the assumptions included in typical calculations, such as the one you've just undertaken, is things like the toilet's flushed 5 times per day times the number of occupants. So if there's 4 people living in the house, the toilet gets flushed 20 times a day. 30 litres of hot water and 30 litres of cold water used per day per person for drinking, washing, shaving, etc. Households that use hoses to water gardens will use an extra 9,000 litres of water a year. If the hose happens to have a trigger nozzle on it, that'll be 4,500. So there's no way you can sort of account for whether someone's going to use a trigger nozzle or use a standard hose to water the garden. So again, you have to just make assumptions. Generally, you would sort of then go, instead of going 9,000 or 4,500, go somewhere in the middle, say 6,000, 6,500 if someone uses a hose to water their garden. But if you complete the online water usage calculation, you basically come out with a good estimation as to the amount of water that's required for a domestic installation, and that allows you then to size your system. So once you can see the amount of non-potable water that's needed, it allows you to size the rainwater harvesting capacity, the cylinder required. And it will depend on the occupancy of the building, the purposes for which the water is going to be used, the efficiency of the appliances that are being fed. And because it doesn't rain every day, the storage tank must be correctly sized to reflect 2 competing factors. And those 2 competing factors are quality of water. So you want good quality water, and for the water to be good quality, it means you need a good turnover of the water. So you don't want the water that you gather sitting stagnant for long periods of time in the storage cylinder. But similarly, you need to have enough of a storage supply to give you continuity of supply, so that if you do hit a dry period, that your rainwater harvesting system will have gathered enough water to see you through that dry period. So you've got 2 sort of competing factors that you need to take into account. But because the rainfall cannot be predicted with any certainty, it means that the storage tank for rainwater storage systems are generally sized so that they can provide about 18 to 20 days demand without any fresh rainfall. So that's the size that you need to make the system, around about 20 to give a house 20 days of supply without any new fresh rainfall. And the operational performance of properly designed systems should be sufficient to provide nearly all of households non-potable water requirements on a year-round basis. And basically that will give a 50% saving on the total water consumption for a domestic application. So it'll save 50% of the water in the house. In workplace or leisure facilities, the balance of water often switches to a greater extent towards non-potable water use, such as toilets, urinals, flushing, ground irrigation, washing of vans, trucks, cars, etc. And hence the potential to reduce consumption in commercial or industrial applications is usually often greater, at around 80-85% reduction in the water use. So in cases where the water is being charged for, an 80% reduction in your water charges is a very attractive proposition. At the moment, where we still have a standing charge, for example in Northern Ireland, they're not metered. The 50% reduction is not realisable, but when water charging does come in, and if it gets charged on a meter basis, then if you can save 50% of your water bill, then it starts to make rainwater harvesting technology look attractive for money saving. The quality of rainwater harvested depends on a number of things. Firstly, good system design, also on using high quality components, good installation practices, and if you get all three of those right, the quality of the water is generally good. If you ignore any of the above requirements or you miss them out, then the quality of the harvested rainwater can be compromised. Water falling from the sky is usually clean, so if you catch the water from the clean, straight from the sky, it's usually clean and pure. It's only when it touches the ground or hits something on the ground that it essentially becomes compromised. Harvest rainwater will be safe for all non-potable purposes so long as the water that's gathered is harvested in line with UK Rainwater Harvesting Association guidelines, and they can be downloaded from the UK Rain Harvesting Association website at the ukrha.org. And also, if the system is installed in line with the relevant British standard, which is BS 8515. Recommended use for rainwater that's harvested in the UK, it's restricted to toilet flushing, washing of clothes, garden irrigation, and external washing of cars and pathways. Well, there's a specific requirement for the harvested water to be of drinking standard, drinking quality, which may occur in places that would be off the main water mains. The water can be purified. However, the costs normally make it prohibitive for most applications, particularly where you have access to the national water grid. It's not cost competitive. So if you can access the national water grid, systems tend not to provide potable water drinking, but it can be brought up to potable water drinking standards by the addition of additional purification devices where required, and specifically where you would be off the national water grid. But in general, it's neither necessary nor recommended due to the added costs.